All right, so second worksheet here, we're taking a look, 7-2 multiplying monomials. So we've done this before. We're talking about special cases though. So specifically what happens when we square. So if we just use the numbers 3 and 2, if we do 3 plus 2 quantity squared versus squaring both 3 and 2. And what we want to show is that these two things right here, they're not the same, okay? They're not equal. So you can't take the quantity squared and write it as just both of these squared. So we notice this is basically 5 squared, right, which is 25, and this is 9 plus 4, which is 13. So they're not the same thing, okay? So when it's written as squared, you cannot just square x and then square 7. It doesn't work that way, okay? You have to take this and write it twice and then multiply it together. This is called a perfect square, okay? So remember, when we do that, we're going to distribute the x first. So x times x is x squared. X times 7 is 7x. Do 7 times x, which is 7x again. And then 7 times 7, which is 49. And then we're going to add our two like terms in the middle. So we get x squared plus 14x plus 49. Okay? And the same thing's going to happen with like h plus 3 squared, or 5s plus 2 squared. So let's take a look at c here. So remember, I'm going to write it twice. So 5s plus 2 times 5s plus 2. All right? So 5s times 5s is 25, and then s times s is s squared. 5s times 2 is plus 10s. Then we do the 2 times 5s, which is another 10s. And then 2 times 2 is 4. So combine like terms, get 25s squared plus 20s plus 4. All right? So all those are pretty much the same thing. I'll let you kind of take a look at those and try to finish them up if you need to. Okay, and then multiplying polynomials. So what happens now when we're doing distributive? So what we're basically getting to here is how to factor with the GCF. So when you distribute through, okay, with the 3 here, remember it's 3 times 8, so this is 24, and then an x, and 3 times 6, which is negative because it's 1 negative, 1 positive, and then 18. What we're eventually going to do is talk about how do we go backwards. How do we take this answer and get it back into what's called its factored form here, okay? We'll talk about that on the next page here. So when we do this one, the 6, just for a little bit more practice, 6 times 2 is 12, x to the 4th times x cubed is x to the 7th, y cubed times y is y to the 4th, and then we repeat. So 6 times 5, and it's negative 5, so this is negative 30. There's 4 x's and 2 x's, so that's 6. And there's 3 y's and 3 y's, which is 6. And then 6x, right, times to the 4th y cubed times x squared plus y squared. There's really a 1 here, so 1 times 6 is 6. And then we have 6 x's and 5 y's. And so this is what we're going to get. So how do we take this and go backwards? That's the next thing. All right, so we're going to go to the next page. And this is called finding the GCF, okay? So the greatest common factor on your calculator, you're just going to go to the calculator page, you're going to press menu, number, and then you're going to go to greatest common divisor, okay? Essentially what you're doing is you're taking the factors of 12, right? So what multiplies give you 12? Well, it's 1, 2, right? 6 and 12. And what about the factors of 14? Well, that's 1, 2, 7, and 14. And you're picking the largest number from each list. So that would be the 2's. So the GCF between those two numbers is 2. Okay? So for 15, what's the biggest thing that divides in both 15 and 24? Right? So if you think about it, 15 is 1, 3, 5, and then 15. 24 is 1, 2, 3, 4, 6, 8, okay, 12, and then 24. So the biggest number they each have is a 3. So the GCF here is going to be 3. For 12 and 144, the biggest number is 12 because it's 1, 2, 3, 4, 6, 12. And then for 144, the biggest number that's going to be there is a 12. Now, what happens if we have letters? So the letters, remember, there's essentially 2 x's here, and there's 4 x's here. So really, how many do they have in common? The biggest amount they have in common is just the 2. So basically, we're going to take the smallest exponent. So the GCF here is x squared. The GCF for the next one, smallest exponent here is the 6. That's a terrible circle. Okay, so this means the GCF is just y to the 6th. Okay, for number 5, there's x's in common, right? So the GCF is going to have an x, and there's also a y in common, so it's going to have a y. The smallest exponent for the x is the 3, so it's x cubed. And the smallest exponent for the y is that 1 that's not written, so it's just 1, y. So it's x cubed, y. Okay, for number 6, GCF, we're going to do numbers first. So the GCF, the biggest thing that divides into 6 and 12 is a 6. There's also an x in common, and the smallest exponent is the 2. So the GCF is 6x squared. Okay, for 7, the GCF of 4 and 18. Biggest number divides into both is 2. Okay, they both have x's and y's, right? And then what's the smallest exponent for the x? It's the squared. The smallest for the y is the one that's not written, which is a 1. And so there's my GCF. Okay. So when you factor, we're going to be looking for 3 things. And the first thing we're always looking for is this greatest common factor. So what we mean by factors is, I want to take this term, 5y minus 30, and I want to break it into the 2 things that multiply together to give me that term. So in other words, what would be the step right before this one? Okay, I don't know why that's there. So what would be right before this in this distributive property, right? It should be something here, and the thing that goes here is the GCF, and then what's left inside here is essentially the quotient when I divide the GCF by this original term. So the GCF between the 5y and the 30 is 5, okay? And if I divide 5 into both of these, what's left over goes right inside the parentheses here. So 5 goes into 5y. When I divide, I get left with a y over. 5 goes into 30, right? And there's a 6 left over when I divide. And the minus sign that's originally here is going to stay. Okay, so for number 2, the GCF between the numbers is a 2, and the letters is an x. Okay, I put down 1 set of parentheses for myself. Okay, so find the GCF, 1 set of parentheses, the GCF goes outside, and then the quotient goes inside. Okay, so if I divide 2x into the 2x cubed, the 2 will cancel. And out of the 3 x's that are there, so you can think of that there, if I put a 2x here, right, these are gone, and then there's just 2 x's, so there's an x squared left. If I take 2x and divide it into 6x, the x's are going to cancel, 2 goes into 6, and there's a 3 left over, and the minus sign stays. So if I did distribute, okay, this back through, I should be able to get my original amount back. Here, the GCF between the 2 terms here is m, 1 set of parentheses, m goes into itself, right, and there's a 1 left over, and m goes into mr, and there's just the r left over. Okay, so let's do a little bit tougher one here. Let's try number 8. So now there's 3 numbers. So what's the GCF of 12, 6, and 3? The biggest thing that divides into all 3 terms, okay, is a 3. All right. They all have a c. Smallest exponent is the 1 at the end, so it's just c. And they all have a d, and the smallest exponent is the 1 at the end. So the GCF is 3cd, and then I put down 1 set of parentheses. So if I divide 3cd into 6c cubed d, 3 goes into 6 2 times. If I take a c out, there's 2 c's left over, and there's no d's left over when I take the d out. And to the second one, 3 goes into 12 4 times, c goes into c squared, and there's a c left over, d out of the d squared, there's a d left over, and then 3cd goes into 3cd, and then when I divide, I just get a 1. So this is just plus 1, okay? And there's my answer. That's the GCF. All right, so let's try one more. Let's do the last one here. Let's do 9. So 37 and 28, the GCF number, right, is 7. And between the x to the 4th and the 7th, I can take 4 away from both. So that's my GCF. So GCF first, one set of parentheses. So 7x to the 4th goes into 35x to the 4th, and there's just a 5 left over. Okay, x to the 4th is all gone. Minus 7 goes into 28 4 times, and from x to the 4th and x to the 7th, it means there's 3 left over. I get left with that. Number 11, a little tricky question, but one of the factors, so one factor of, this is the original one, that means one factor, okay? Here, there's 2 factors here, okay? The 7x to the 4th is the first factor, and the 5 minus 4x cubed is the second factor. So from this original amount, this is one factor. This essentially is my GCF, okay? So if I take 14x squared y cubed out of this 56x to the 4th y cubed, what's left over? So 14 goes into 56 4 times. If I take 2 x's out of the way from the 4, there's 2 left over. 3 y's away from the 3 that are there are none left over. 14 goes into 42 3 times. I take 2 x's away from the 2 that are there are none left over. 3 away from the 6 from the y's, there are 3 left over. And so the other factor is the 4x squared y cubed. That's the other factor. Okay? And it would be the same thing here. So for the last question, the area below is 5x squared plus 15x. This is what's left over. This is one factor. So basically, I want to factor here again with the GCF. The GCF here is 5 and then x. So if I take a 5x out of 5x squared, I get x from the first term, and then 5x goes into 15x, and there's a 3 left over. So this is the one, that is the width, which means that this 5x is my length. Okay? That's it for distributive property, and I'll send the other video on to you later.